Two particles of masses 5 kilograms and 4 kilograms respectively are connected by a light, inextensible string passing over a smooth fixed pulley. The particles are released from rest. Calculate in terms of g the acceleration of the particle and the tension in the string. So again, we set up the situation where we draw them out and look at them. The acceleration is going to be down because movement is going to be down. So we're going in an anti-clockwise movement according to this diagram. Okay, so force on this one is mass times acceleration, so that's going to be 5a, and it's also 5g minus t. So then I can say that 5a is equal to 5g minus t, so my tension is 5g minus 5a. On the 4 kilogram mass, the tension's going up, 4g going down, and the acceleration is moving up. So this time force is mass times acceleration, so it's 4a, so it's going up, so it's t minus 4g. So our 4a is equal to t minus 4g, so t is equal to 4g plus 4a. I put these two equal to each other. 5g minus 5a is equal to 4g plus 4a, and I get that g is equal to 9a, or 1 over 9g is equal to a. That's our acceleration. Then we have to look for the tension, and in this case I simply substitute 1 over 9g into either of these equations, and you will get that your tension is 40 over 9g. The second situation, if after 2 seconds the larger mass is caught and held, how much further will the lighter mass rise? Okay, so we're looking for distance here, so we're going to use a formula that has distance in it. So we could use v or s equals ut plus a half at squared, or v squared equals u squared plus 2as. Okay, now if we're going to use s equals ut plus a half at squared, we need to know the time, but we don't know how much time it moves. So that's no good to us. The one that has less variables in it is v squared equals u squared plus 2as. Now we know that in the end the v will be 0, but we need to work out the u. So to work out the initial speed after 2 seconds, so the speed after 2 seconds, we work out the speed after 2 seconds by using v equals u plus at. So v is equal to 0 because it started from rest, plus a, we're going to use our a in this case is going to be 1 over 9g, and then our t is 2 seconds. And we get v is equal to 2 over 9g. So that's the speed after 2 seconds. So when we're moving to using this formula, v squared equals u squared minus 2as, our final speed is going to be 0 because we want to know how much further it moves. So that's going to be 0, and our u is going to be this, the speed after 2 seconds. Our a, which is the acceleration, now remember, the only acceleration on this now is gravity because the heavier mass is being held. So gravity is the only force here, so we use v squared equals u squared minus 2as, so we substitute in 2 over 9g for u squared, and we substitute g in for a, and we work that out and we get 2gs is equal to square out this, so 2 squared is 4, 9 squared is 81, and g squared is g squared. And then we divide both sides by 2g, and we get 2 over 81g.